All right, hello students. So you've just watched in the previous video how to use a graduated cylinder and how to properly read a graduated cylinder. So that would be the volume of liquids. Right now I'm going to go over how to find the volume of a regularly shaped object, such as this cube, and then an irregularly shaped object, such as that rock. Okay. And so for the regularly shaped object, finding the volume of it is basically finding the length times the width times the height. So here, this is the only centimeter ruler I have in my house. You can see how the centimeters are right here. And so when we measure it, thank you, Aurelia. When we measure it, it goes until 3.8, here, move your finger back. It goes until 3.8 centimeters, so 38 millimeters. And since this is a cube, all of the sides are going to be the same. So this side is the same, and then that side is the same. So so that's 3.8. For the rock, it's a little bit different because it is a very irregular shape. So we need to figure out how big the volume is of this rock. And to do that, we're going to be doing something called displacement. So if you've ever had a glass of water, so I've got like water right here, and then you put something really big into it and then the water overflows the sides, that is because of displacement. Basically, the liquid is, or whatever the object is that you're putting in the water, it's taking the place of the water. And so the water is moving up, however big that object is. So what we are going to do is, I don't have a graduated cylinder at home, so I made a little one here. So see that blue line? That is going to be how far up the water is that I'm going to fill it. So I'm going to go ahead and fill it, hopefully that line. Okay, all right. And so it's a little bit over, but it's not too bad. And so now what I'm going to have my daughter do is she's going to gently place the rock in the container. So go ahead and do that. Oh, there we go. Perfect. Now you'll notice, right, that the volume of the water now is way higher than that line. And so that tells me if I can measure the difference between where the water started and where it ended, that is the volume of the rock that is in there. Let's leave that right there. So that would be, right, an irregularly shaped object. Let me just get the rock back out here. Okay. And I'm going to refill this. Okay. All right. Now, another object that I have, so the rock, right, is one object, and the other object is this bolt. Now you can see the rock has a much larger volume. I hope we can all agree that the volume of the rock is a lot bigger than of the bolt. So go ahead and take this. My daughter's going to place the bolt in it, and you'll notice that it only went up just a little bit, right? Because this bolt has less volume than the rock did. So that is one way that we could figure out the volume of an irregularly shaped object, or an object that we can't easily measure the volume. So again, density is all about mass divided by volume. So we want to figure out how big the volume is of, you got it, of the objects, and then from there we can then calculate the density. So how tightly packed the atoms are. So I have a block of wood, I have a rock, I have the block of wood, here, let's put it down. I've got the rock, and then I have the bolt, okay? we have the volumes of each of these now. So let's say that that little container had the was a graduated cylinder, and we could figure out the volume of it. Now that we have the volumes, now we can measure the mass. That's the other piece of information that we need. Awesome, thank you, sweetie. Okay, I'm going to use this in just a second. So we have what is called an electronic balance. And I think that we've used these before a little bit when doing the Cold Pack Engineering Design Challenge. We did that. And so this is just basically, it is like a something that measures mass, that measures weight, right? So when I turn it on, when I turn it on, no, hang on. Here, let me lay it flat. When I turn it on, it'll say hello, and then it'll say 0, right? So we want it, and it has grams. So my daughter's going to go ahead and put the block on. So the mass of the block is 16.8 grams. Okay, now go ahead and take the block off and put the rock on. The rock is 66.8 grams. Okay, and then take that off and put the bolt on. And the bolt is 10 grams even. Awesome, perfect. So that now we have the mass of each. So go ahead and take that off. Of each of our solids. Now, sometimes I'm going to have, and you're going to need to get the density of a liquid. And the volume of a liquid is pretty easy, but the mass of it is a little bit more difficult. So, I'm going to put this down. Okay. So what we have is, let's say we want to find the mass of the liquid that is in this container. Okay. So the mass of the liquid and the container it's in is 163 grams. And to find the mass of just the liquid, now we need to take the liquid, and we're going to pour it out, so no liquid is in there, and then we're going to get the mass of just the container itself. So the container itself was 102.2. And so we can then subtract 102.2 from the original amount, and that will give us the mass of the liquid. The other way we could do this is we could zero out the scale. So if we have the container on the mass, on the scale, then go ahead and hit the T. You hit the tare button or the zero out. Notice how now it says 0. So now it's not taking the mass of the container, it is taking the mass of anything above the container. So I'm going to fill the container now to the line, and now we can get the mass of just the water inside. So again, density is mass divided by volume. So we're trying to figure out how many atoms are packed into a certain amount of space, which is the volume. And in just a little bit, I'm going to talk to you about how to calculate the density. So now that we've measured all of these, now we're going to take these numbers and we're going to calculate the density.